We're going to continue investigating limits, and today we're going to look at the limits of rational functions. We're going to use a graphing calculator to help us out. So the first limit we're going to look at is the limit as x approaches 3 of x squared minus 9 over x minus 3. So we're going to go ahead and put this in the calculator. Make sure to put parentheses. Okay, and if we graph, we get a line. Okay, and this isn't unexpected from what our last lesson. So now I'm going to take this table of values, and what I can do is use the table feature. So if you go to second table set, we're going to start our table at 2.88, and then our delta is 0.04. Then we go to table, and these are all the values that we're going to plug into our chart. So here's the table of values. This function is undefined at 3, which again should not be surprising, since if we plug in 3, we're going to get a 0 in the denominator. But if we look at this numerically, there is a limit. So we're going to look at the limit from the left and from the right. So we're looking at the limit as x approaches 3 from the negative side. So as x approaches 3, what are these values doing? Well, they're getting closer and closer to 6. From the positive side, they're also approaching 6. So since both the left-hand limit and the right-hand limit are the same, we can say that the limit exists and is 6. We saw that the graph is a line. And then the key is here to factor. Just like we would to find a point of discontinuity, we factor. So x squared minus 9 factors to x minus 3, x plus 3. Those cancel to just x plus 3. So what is the value of f of 3? There is no value. There's a point of discontinuity there. But I can still arrive at the limit using factoring. So the limit as x approaches 3 of x minus 3 times x plus 3 over x minus 3. Those cancel, which leaves me with the limit as x approaches 3 of this, which we can evaluate by plugging 3 in for x. So that would be 3 plus 3, which is 6. We're going to do the same thing here. So the limit as x approaches 1 of x cubed minus 1 over x minus 1. If I tried to evaluate that limit right now, we'd plug in 1 and you'd get 0 over 0. So we have to do more investigation in that case. So again, I'm going to fill in a table of values. So I encourage you, pause, go ahead and fill out this and try to see if you can get these limits. So here's our table of values. So x approaches 1 from the negative side, those values are approaching 3. When we approach it from the positive side, we're approaching 3, which means the limit exists and is 3, even though the function is still undefined. So let's look at the algebra that would lead us to this same conclusion. So if you factor x cubed minus 1, which is the difference of two perfect cubes, it factors out like this. So then the x minus 1s cancel, which leaves you with x squared plus x plus 1, which we can certainly evaluate that limit. So we're going to plug in 1. So this is going to be 1 squared plus 1 plus 1, which is 3. So the conclusion, which is again unsurprising, is it is possible for the function to have a limit even if the function doesn't exist at that point. All right, so let's do another one of these. So we have x plus 3 over x squared minus 9. So again, we're going to fill in this table of values and do these limits. So here are our values. So as x is approaching 3 from the negative side, these numbers are getting more and more negative. So it's going to negative infinity. As we approach it from the positive side, those values are getting bigger. So there it's going to infinity. And if you look at the graph, there is actually an asymptote there. Okay, so negative infinity and positive infinity are not the same thing. So this limit does not exist, and the function value does not exist. But how can we tell that analytically? Okay, how can I tell from this equation that there is no limit? When we have the graph in the table, it's pretty obvious, but how do we do this algebraically? So let's look at the factoring. So we factor the denominator here, which gives me x plus 3, x minus 3. The x plus 3's reduce, so I'm left with 1 over x minus 3. So if I plug in 3 here, we have 1 over 3 minus 3, which is 1 over 0, which is undefined. So when you do the factoring, if after you've removed any discontinuities, it's still undefined, that means there's not going to be a limit. Okay, so the key here is to factor. We had an example that had the difference of two perfect cubes, so I'll go ahead and give you the sum formula and the difference formula. So the sum is going to be a plus b, a squared, minus ab, plus b squared. So that should be a minus. A minus b, a cubed minus b cubed is a minus b, and then this is going to be all pluses. All right, so let's do some limits. So first thing is you check, can you plug this value in? And in this first one we can. There's no issue, because if I plug it in, I don't get a 0 on the denominator. So I can just plug this one in. So we're going to have 4 minus 4, which is 0 over 4, which is just fine. This limit is 0. But if we move to this next one over here, if I try to plug in negative 2 into that same equation, there we do have an issue because we're going to have a 0 in the denominator. So that does not mean the limit is undefined. It means we have more investigation to do. That investigation involves factoring. So we're going to factor the top. And that x plus 2 over x plus 2 cancels. So then we're left with the limit as x goes to negative 2 of x minus 2. This I can evaluate. So we plug in the negative 2. So we have negative 2 minus 2, which is negative 4. So our limit exists and is negative 4, and we can find that analytically by factoring. Okay, we'll do another one here. So the limit as x goes to 4 of x plus 4 over x plus 4 x minus 4. The x plus 4's cancel. So we're going to have 1 over x minus 4. We plug in the 4, and we get 1 over 4 minus 4, which is 1 over 0, which is undefined. So there is no limit here. If we were to graph it, it would be an asymptote. This one we're going to use the difference of two perfect cubes. So we're going to have x minus 3 and then x squared plus 3x plus 3 squared, which is 9. So the x minus 3's cancel. So we're left with the limit as x goes to 3 of x squared plus 3x plus 9. We will plug in 3, so 3 squared plus 3 times 3 plus 9. So that's going to be 9 plus 9 plus 9, which is 27. This next one, we're going to do the same thing, but we have some work to do first. First thing I want to mention, there is a typo. This should be f of negative 1. So we want the limit as x goes to -1 of f of x minus f of -1 over x minus -1, where our function, f of x, is x squared minus 2x. So we're just going to fill in the information here. So f of x is this entire thing. So x squared minus 2x. Then I want to subtract f of -1. So I'm going to plug in -1 into my equation. So we have -1 squared, which is 1, and then a -2 times the -1 is a 2, so 1 plus 2 is 3. So we're going to be subtracting f of -1, which is 3, over x plus 1. Past this, it's just going to be the same thing. We're going to factor. And I will give you a hint on the factoring here. If this is going to simplify, x plus 1 has to be one of the factors. So even if this is a complicated factoring problem, it's really not, because we already know what one of the factors has to be. We just have to figure out the other one that will give me these values. Specifically the -3, well, I'd have to multiply by a -3. Okay, the x plus 1s reduce. So we have the limit as x goes to -1 of x minus 3. So that's going to be -1 minus 3, which is a -4. Now, right now, this is just the limit. In our next lesson, that number will have a specific purpose. Okay, so similar problem. You might try to do this one on your own first before you watch the video. So we're going to have f of x minus f of 2 over x minus 2. So I'm going to figure out what f of 2 is first. So 3 times 2 squared minus 4 times 2 plus 1. Okay, so that's going to be 12 minus 8, which is 4, plus 1 gives us 5. So now we're going to plug our information in here. So we're going to have the limit as x goes to 2 of f of x, which is 3x squared minus 4x plus 1, minus f of 2, which is 5. Okay, we'll simplify that down, and then we'll factor. Again, this is easy factoring because I already know what one of the factors better be, which is x minus 2. Then I just look at this equation, and what would I need to multiply this by to get this? Well, to get the 3x squared, I'm going to need a 3x, and to get a -4, I'm going to need a positive 2. Okay, then I can reduce. And then we plug in 2. So we're going to have 3 times 2 plus 2. So 6 plus 2 is 8. Again, this number will have significance for us soon, but for right now, we're just evaluating the limit. Okay, a similar type problem here. We're going to find the limit as h goes to 0 of f of x plus h minus f of x. All over h. So we can't just plug in 0 because that's going to be undefined. So the limit as h goes to 0 of f of x plus h. So wherever I see an x, I'm going to replace that with x plus h. So 3 times x plus h squared minus 4 times x plus h. That is f of x plus h. Now we're going to subtract f of x, which is 3x squared minus 4, all over h. Now we just have a bunch of algebra to do. So we're going to simplify that numerator. I'm going to start here by foiling x plus h times itself. So that's going to be x squared plus 2xh plus h squared. I'll distribute through that negative 4 and distribute through that minus. All over h. And then the last step is to distribute, and then we're going to start crossing some stuff off. So we have 3x squared plus 6xh plus h squared minus 4x minus 4h minus 3x squared plus 4x all over h. So let's look at what we have here. We have a positive 3x squared and a minus 3x squared. We have a negative 4x and a positive 4x. So that leaves me with 6xh plus h squared minus 4h all over h. Well, everything in that numerator has an h in it, so I can divide all of them by h. And this limit just goes along for the ride until we get that. So 6xh divided by h is 6x. H squared divided by h is h. And then negative 4h divided by h is negative 4. We're evaluating this limit as h goes to 0. So I'm going to plug 0 in for h. Everything else stays the same. So this is going to be 6x plus 0 minus 4, which is 6x minus 4. Now I'm noticing I made a little mistake here. I forgot to distribute. This should be a 3h. But it doesn't affect us in the end because 3 times 0 is still 0. So this is how we do limits of rational functions. We will use this next class when we're talking about tangent lines.